In this lesson, we'll create 3D tooling from our 3D parametric inserts that we created. So again, I'll start out in the Lathe Tool Manager, and in our machine group I'll right click and create a 3D tool. So I've got a name ready to go for our tool. We'll call it a right hand 35 degree 16 thousandths R left side insert down tool. Now you notice our number incremented by 1 because we already have a tool. I am in inch and I'm ready to create my holder. Now this is the same interface we looked at before, so I can select it from a step file, from the graphics window, or in this case we're going to open it from a library. So there's our holder that we have currently in our lathe_inch library, and MasterCAM brings that in. You'll notice that it also brings in a lot of information with it. So we've still got general turning. We didn't change MasterCAM. I will say requires locator. It brought back, it already knows that it's 1 inch thick by 1 inch wide, and our plane is properly defined. So next I'll go to our insert, and I need to create a new insert. So I'll select the new insert button. And again, you see the red outline. We don't have anything in there right now. I'll open from a library, and I can select any of these new inserts that I just created, as well as the custom insert that we put down into this insert library before. So I'm making a 16 thousandths nose radius insert here. So we'll select that. And let's take a look at what we have now. So there's our insert. That's where MasterCAM put it. So I'll continue on down with creating this, but I just wanted to show where it came in. So we do need a name here, and we're going to call this 4140 steel, because we're going to create another cutting definition for 1215 steel, and we'll see how that works. So it brings in the corner radius for us. It also updates the tool offset number. Now this is a right hand tool, so we need to make it a right hand tool. And that's all for this panel. I'll move down to mating. Now we haven't mated before. I need to take that insert and I need to bring it up and put it in the pocket. So in this case here, I'm going to go with parallel. I'm going to grab a face and an edge. So now it wants a flat face on the holder, and I'm going to select an edge on the holder. So you see it mated very nicely. If I needed to, I could have used dynamic transform once I got it close, and depending upon the situation, I might need to use a coincident mating feature or a perpendicular. But again, in this case, parallel worked very nicely, and it moved straight into that pocket very nicely. So next is setup, and for our plane, we'll pick the top of the tool. This is just like we did on the last tool. We're all set there. The boundary comes in good. It looks good. I have no red or orange outline on my boundary result. For machine orientation, this will be vertical. It is on the top turret. I have no tool angle. The default active spindle is left. However, my spindle rotation, I want this tool to point towards the left spindle. And just like we did the last time, I'll make the direction counterclockwise. I do need to go in and set up the compensation again. So I'll use the 3 points this time to do something different. So I'll grab the point on one end, in the center, and on the other end of the arc. And you can see it brings back 15.62, 15,006 25 millionths. We do want the corner method. Our quadrant looks good. We're in the right quadrant. Our plunge and cut direction again are good. So now we just need to do our tool clearance. I'm going to do both side and end clearance first, and then I'll grab my height and then my width. So just like we did the last time, we'll fill in all this information. Now here I'm going to change my parameters a little bit because we set a cutting definition for 4140 steel. We'll make another cutting definition in just a moment. So I'm going to make my spindle speed 450. I'll make my feed rate 0.007, and we'll call that good. Now we could change other things here obviously, but just so we have something different. Okay, so we have a 4140 steel cutting definition, but I want to use this insert in more than one application. So I'm going to go ahead and make a new cutting definition. And you'll see that the insert, there's really no changes I can make here. Corner radius, I'll go out and select it. Now it's possible if this was a grooving tool, I might have a couple different corner radiuses on this thing. It's another use for cutting definition. I might want to change my tool offset number. In this case, I don't. We still have a right hand tool, so we're good there. So all this is still going to be good all the way down through. But down in our, oh, I do need to set up our compensation again. So I'll go out and I'll use two adjacent edges. This is all good. We'll grab our side and end clearance. Then we'll grab our clearance distance. Okay, so this is where things really change here. Now actually things could have changed in a few places, but I only have one insert. If I had a grooving insert or a custom insert, some of these other parameters might have changed based on the tool. But here I'm going to cut 12L16, and I didn't name it correctly. I'll come back. We'll call it 1215, and we'll make our feed rate 8.5 thousandths. So let's come back up top here and we'll name this 1215 steel. So we'll check out of here. You'll notice that I have a 4140 steel cutting definition and a 1215 cutting definition. So we'll green check out of here. And you'll notice that I have this little icon up in the upper left hand corner. That designates that we have more than one cutting definition, and I'll show you how to use that in a toolpath so that we can select the cutting definition that we want to use.